Hello, my name is Dylan Losey, and at ICRA 2018, I'd like to tell you about our research, trajectory deformations from physical human-robot interaction. This paper was previously published in the ICRA Transactions on Robotics. Robots are increasingly working in collaboration with humans. Traditionally, we use impedance control so that the human can safely interact with the robot. Impedance control also lets the human compliantly adjust the robot's current trajectory. But, importantly, impedance control alone does not let the human change the robot's future behavior through physical human interactions. In this research, we propose a real-time method to smoothly and safely deform the robot's future desired trajectory in response to human interactions. To better understand our trajectory deformation method, let's look at a simulation. Here, in the top plot, we have a human applying a force for either 0.1 seconds, 0.5 seconds, or 1 whole second. In the bottom plot, we show the robot's desired trajectory. Originally, the robot is tracking a sine wave. As you can see, however, the longer the human interacts with the robot, the greater the change in the robot's desired trajectory. The trajectory deformations aggregate smoothly over time. In collaboration with Andrea Baici and Anka Dragan at the University of California, Berkeley, we have applied our trajectory deformation method to learn the human's objective function during the current task. In this experiment, a robot is trying to carry a cup from the top of a cabinet down to a table. Unfortunately, the robot doesn't know that it should keep the cup upright. During the task, a human participant interacts with the robot and tries to correct its motion. Using our trajectory deformation method, the robot learns which features are important to the human and then replans the rest of the task accordingly. To find out more about trajectory deformations and how they can be used to learn the human's objective, please see the following publications or come to my booth. Thank you.